that chemical reaction, we are actually using the stoichiometric coefficient. I have already explained that what is stoichiometric coefficient, isn't it? For that, see what we have done, that if I take a reaction, suppose A to B. Okay, this is the chemical reaction. Here, what did I tell you? That moles of A divided by moles of B. This will become equal to the stoichiometric coefficient of this A. Stoichiometric coefficient of A is what? Divided by stoichiometric coefficient of B, that is B. So using these two, I can actually write that Na by A is equal to Nd by B. Using this, we had one numerical also. In that numerical, we have seen how to calculate moles or weight, whatever they have asked. So this is one more formula. These are the formula for calculating moles, and using this formula, when moles and stoichiometric coefficient are related to each other. Okay, let us do one or two more numericals, that is, so that this concept becomes clear to us, and then we will start a new concept. Okay, so I am going to use this concept today. We have solved one numerical. Okay, let us solve some more numericals using this concept. So see, if I write down, this is question 1. Okay? Suppose the question says 8 gram of methane is combusted in excess of air. 8 gram of methane is combusted in excess of air. Find the volume of CO2 liberated at STP. Okay, this is the question. So see, methane is given. I have also written natural gas also. Natural gas means it is methane gas. So 8 gram of methane gas is combusted in excess of air. Find the volume of CO2 liberated. Now, first thing you should be knowing that any hydrocarbon, when it undergoes combustion, if it is complete combustion, because it is excess of air, means it will get ample of oxygen. In that case, complete combustion of this hydrocarbon is going to take place. And whenever combustion of any hydrocarbon takes place, the products are always carbon dioxide and water vapor. Okay, so here also see, this is CH4 or combustion with excess of oxygen, which will give me carbon dioxide and water. Now, my first thing is, whatever is the question given to you, I need to write a balanced equation. This is the first thing you have to do. Now, here, if I balance the equation, I can clearly see by between trial method, then if I just write a 2 here, stoichiometric coefficient, 2 here, the equation gets balanced. Okay? And one more thing I will teach you here itself, see, I am writing a general formula that will help you to balance any hydrocarbon given, combustion of any hydrocarbon. If they ask you, using this general formula you can balance. And what is the general formula? CXH1. This is the hydrocarbon. Okay, X and Y are the how many atoms of carbon, Y is the atoms of hydrogen. Plus X plus Y by 4. This much oxygen will give me X of CO2 plus Y by 2 H2. This is your general equation. Here also see one carbon, there are 4 hydrogen, and oxygen. general formula which will help you to balance any combustion of hydrocarbon. Okay, so see, if you use that formula, you can actually balance this also. What is x here? Here x is 1 and y is 4. So this becomes 1 plus 4 by 4 means 1, that is 2. Isn't it? And x is what? X is 1. So 1 CO2's coefficient of CO2 will be 1. And y by 2. Now what is your y? Y is 4. So 4 divided by 2 means 2. So you can balance any hydrocarbon combustion. That is the equation of combustion of any hydrocarbon can be balanced using this formula. Okay. Now see, I'm dropping this. This will help you note it down. What we are going to do is next is we are supposed to find out the volume of CO2. So see, here first thing what I am going to do is I have told what is the formula which we are going to use. Moles of methane divided by its stoichiometric coefficient, that is 1. And what else do I need? Carbon dioxide. So moles of CO2 divided by the stoichiometric coefficient of carbon dioxide, that is also equal to 1. Okay? Now, here I can calculate the moles of methane. What is the formula I have taught you? That to calculate moles, weight divided by molecular mass or molecular weight will give you moles of methane. So, what is the molecular weight of methane here? It is CH4. Carbon is 12, hydrogen is 1, 4. So, that is 60. So, my weight is 8 divided by 60, that is half. Okay? So, here what will I write? Half divided by 1, that is half, is equal to moles of CO. Now, if you remember, I have taught you one more formula how to calculate moles. Whatever volume and density is given divided by 22.4 liter, you can calculate moles. So here see, I got this formula as half. Still, I need to calculate the volume of CO2 liberated. So what will I do? I can write moles of CO2 can be volume of CO2 at NTP at STP divided by 22.4 liter. So using these two, I can actually equate these two and I will get what is the volume of CO2. That is equal to 22.4 divided by this 2. That is 11.2 liter is the volume of carbon dioxide liberated at STP. So why am I doing this numerical? Because you can very well see that using this concept I can solve numerous numericals very easily. Okay? Clear to everyone? One more question we will do. Okay. Second question. After getting X gram sodium bicarbonate, 5.6 liter CO2 is evolved at STP. Okay, find the value of X. This is the question. So here see some mass of that is X gram of sodium bicarbonate is taken. It is heated and CO2 5.6 liter of CO2 is evolved at STP. You need to calculate are 6, 3 plus 2, 5 plus 1, 6. So the equation is balanced. Now, again, my general formula is what? Moles of sodium bicarbonate by stoichiometric coefficient is equal to what am I supposed to calculate? CO2. So moles of CO2 by stoichiometric coefficient of carbon dioxide at this form. Okay, this is my general formula which I can use. Now, here 5.6 liter of CO2 is evolved at STP. If volume is given to you, you can calculate moles of CO2, isn't it? What is the formula to calculate moles when volume is given? Whatever volume is given divided by 22.22. So this becomes actually 1 by 4. So this value is what? It is 1 by 4. So what will I write? Moles of sodium bicarbonate divided by 2 is equal to 1 by 4. Clear? So here I am actually getting moles of sodium bicarbonate will become equal to 2 by 4, that is equal to half. Clear? Now, what are we supposed to calculate? I mean, how much is the weight of NaHCO3 taken? Here, once I have got the moles of sodium bicarbonate, the moles formula is again weight by molecular weight. Now, what is the molecular weight of NaHCO3? You need to calculate. Sodium is 23, hydrogen 1, carbon 12, oxygen. It will become what? Oxygen 16 to 3, that is 48. So if you add it up, you will get 10, 15, 6, 7, 8, 84. Isn't it? So here see what will I do? Weight I need to calculate. Molecular weight is 84. Okay. So finally actually if I look at half is equal to W by 84. And I'm having this first line. So how can I calculate my weight? Weight will be 84 divided by 2. That is 42 gram. How much gram of sodium bicarbonate is taken? The answer is 42 gram. So you can understand that these numericals will be easily solved if you use this mole concept with stoichiometric this formula. Okay? And last one more question I will show you. So the third question is 10 gram calcium carbonate is heated. Find the weight lost. Okay, this is the question. 10 gram of calcium carbonate gram of sugar. Okay. Still, if I ask you how many cups of tea can you make? You have 1 cup of milk. Still, you will see that you can make 1 cup of tea. Isn't it? Why is it so? Because your milk is only 1 cup. So what does it mean? That this 1 cup of milk is actually deciding that how many cups of tea you can prepare. Isn't it? So I will say that this 1 cup of milk is actually your limiting reagent. And from this 100 gram of sugar, 50 gram of sugar is used, and remaining I will say 50 gram of sugar is extra. So this will be left behind. And you can prepare this 1 cup of tea. So remember, whenever you are going to solve these limiting reagent numericals, the first thing you should know that whether the given question is a limiting reagent numerical or not. Okay? Second thing you need to find out that out of your reactants, because in limiting reagent numericals, there has to be minimum 2 reagents. Okay, only A is giving me that kind of questions will not come under limiting reagent. There has to be minimum of 2 reagents. Okay, and out of those two, second step will be find out who is your limiting reagent. And third step will be using that mole concept with stoichiometric coefficient, you can solve that what will be your beta, how much will be your beta. Okay, we will solve some questions using this limiting reagent also so that you will get an idea. Okay, now in general if I write an equation, suppose I am writing 2a plus 3b gives me 4c plus 5b. This is a question given to you. Okay, now what else is given to you in this question? Suppose Na moles of A reactant is 10 and moles of B reactant is 50. This is also given. So what are they asking you? First thing they will ask you, who is the limiting reagent? A is the limiting reagent or B is the limiting reagent? And so the question says, find the limiting reagent and also find out moles of C and moles of B. Okay, so this is what you are going to find out. So see, what am I saying you? What is the first step? Whenever you are going to solve a limiting reagent, first step is you need to understand that this is a limiting reagent numerical or not. And how will you determine? For that, what you are going to do is you are going to find out the ratio. The ratio of what? The ratio of stoichiometric coefficient and the ratio of these moles. I am talking about the reactants. Okay, so what are the ratios you are going to find out? You are going to find out the ratio of the moles of the reactant. That is A is to B. What is this ratio coming? 10 by 50. So this becomes 5 into 5, and the value will come up to 25 moles. Clear to everyone? So this is how I am going to calculate moles of CNT, and I have also found out which is my limiting reagent. Clear to everyone? One last question we will do so that this concept is even more clear. See, I'm writing in number 4 question. Suppose the question says, if 54-gram aluminium is heated with 160 gram of oxygen, find the weight of product. Now, again, see in this question, first thing is you need to write up the equation. So, aluminium, whenever it reacts with oxygen, what will it give us? It will give us aluminium trioxide. That is Al2O3. How will I balance? It becomes balanced. Okay? What you are going to do is just using it in hand, you can easily balance this equation. Now, once I balance, once you have balanced this equation, first step is whether it is limiting reagent numerical or not. So that what I have told you to do, you are going to calculate the ratios of stoichiometries. That is 4 by 3. This is stoichiometric coefficient of aluminium divided by stoichiometric coefficient of oxygen. The ratio is 4 by 3. As well as you are going to calculate moles of aluminium divided by moles of oxygen. Now, what are the moles of aluminium? 54 gram is given. Atomic mass of aluminium is 27. So 54 divided by 27 is actually 2. 54 divided by 27, this value is 2. So 2 moles of aluminium and oxygen, atomic mass is what? It is 32. So 160